high-performance sailboats. As you already know, marine architects have always tried to put up more efficient sail plans to generate more horsepower, at the same time designing a better hull to overcome the coefficient of underwater drag. A Southern California engineer and amateur naval architect, Sid Shutt's taken a different approach to the problem of the lift-drag ratios associated with high-performance sailing. Sid says, forget about the hull. Just make it strong enough to support the sail plan, attach a few well-designed hydrofoils here and there, and see what happens. But here is Sid to tell you how his concept works.
It lifts off in winds of about 6 to 7 knots. And once I can get up on the foil, I can get up to a little better than twice the speed of the wind. The best I've done is only about 23 knots. The sensation of high speed, but sort of an effortless power sort of thing.
More efficient sail plans to generate more horsepower at the same time.
The foil is a horizontal wing, hydrofoil. Looks just like a small wing at the bottom of the vertical blade, which is just like a centerboard. And that lifts everything out of the water. The remaining parts of it is only there to balance the main foil. Now, the way that happens, there's a planing surface riding out in front of the main hull, and that rides along the surface of the water. If the main hull, it's too heavy and sinking down, you see, as it sinks down, it's rotating around the front planing surface, so as it drops down, the angle of attack increases. And as the angle of attack increases of the main foil, it produces more lift for the same speed. Now, the little foil that's riding out to windward is a little somewhat smaller than the main foil, and it's inverted so that it's pulling downward as it moves along. And that's pulling a cable that's attached to the top of the mast. So it balances the sail forces fairly directly through a cable in tension. So it's a closed-loop servo system using the forces of the thing you're controlling to produce the change that you need to control the angle of attack to maintain the balance of forces.
That's okay. I don't understand it either. Like most high-performance boats, Sid's boat, too, is slow through the eye of the wind. This is good, though, because Sid has a lot of things to do when he tacks. He has to undo the main sheet from the boom, swing the outrigger and hydrofoil across the transom, hook the main sheet back up, readjust the angle of attack of each individual hydrofoil, and finally, adjust main sheet tension once again. And now he's off. Everyone who sails a high-performance boat knows that added weight equals diminished speed. It's a trade-off. Make them light, but not too light.
Another advantage in a small boat like that, we hauled it out, took it home, and glued it back together the next day and had it out sailing again the day after that. So it broke up Wednesday and we were sailing Friday, and it was no big deal to fix it.
What took Sid years of design work in his backyard testing tank to develop comes next.
That was a segment of Dad's hydrofoil sailboat in Warren Miller's Hot Yachts, filmed in 1972. Dad's son, Steve, helping to set up the boat in the film, is me, and it's now 1995. Dad let me borrow his Super 8 film, which was filmed over the period 1968 to 1974, to make this video.